Welcome. We want to consider another example of function composition and finding its domain. Here, our function f is 1 divided by x plus 1, and our function g is x squared minus 6x plus 8. So the composition f of g of x, that is the composite function, this is equal to f of g of x. And again, I'm going to do the same thing that I did previously, and I'm going to take the function f, and I'm just going to plug g in for x. So I have 1 divided by x plus 1. 1 divided by x plus 1. But the thing that I'm plugging into f in this case is g. So this is g of x. Now I can write this as 1 divided by x squared minus 6x plus 8, and I still have a plus 1 right there. This, of course, is 1 divided by x squared minus 6x plus 9. And if we really wanted to, we can observe that this is 1 divided by x minus 3 being squared. Right? If I wanted to factor this denominator, I can do so. Why would I want to do that? Well, because the natural tendency is to compose the function and then look at the domain of this new thing, which works in this case, but does not always work. So I'm going to put a question mark here, domain of f composed with g. Is this indeed negative infinity up to positive 3, and then from 3 to infinity? Why would it be that? So question marks here, right? Question marks. I don't know if it's this. I would like it to be because 3 is the only thing that would cause division by 0. And again, in this case, it's going to work. So we'll consider another example where it doesn't as well. But to give an example of the process by which we always want to determine the domain of the composition, we're going to first find the domain of the innermost function, that is the domain of g of x in this case. Now, g of x itself is just a polynomial, so I can plug in any number that I want, right? I don't have radicals that are going to cause the even root of a negative number. I don't have division that's going to cause division by 0. So I can plug in any number that I like, from negative infinity to positive infinity. Now I consider the domain of f of x. Now the domain of f of x is going to be slightly restricted because I do have the possibility of division by 0 here, because I have division. This is not a complicated or a very there's not a lot going on for the function f. It's pretty clear that I can't plug in -1. -1 plus 1 would cause division by 0. So what I'm going to do is I'm just going to state that. So the domain of f of x is from negative infinity up to -1, and then from -1 up to infinity. We've just plucked out that single point of -1. Now, if the question, right, if we think back to earlier when we just talked about the domains of functions, if I wanted to identify, right, if my whole question was, what's the domain of f? Well, then I would have to show some work. But in this case, it's just one step in the larger problem, so I'm not worried about showing this, right? The point of this problem is not, can we find the domain of f? The point of this problem is, can we define the domain of the composition? So we need to find both of these domains. Now what we want is we want to observe that we cannot have g of x being -1. So this tells us that we can't have g of x being equal to -1. Why can't it be that? Well, because whatever I get out of g of x has to be in the domain of f, right? G of x, whatever it is, has to be in the domain of f. So we can't have g of x being -1 because -1 is not in the domain of f. So that would give us x squared minus 6x plus 8 being equal to -1. Add 1 to both sides to get x squared minus 6x plus 9 is equal to 0. This, of course, factors exactly the same way that we did earlier, as x minus 3 being squared. This gives us x minus 3 is equal to 0, and x is equal to 3. So we can't have x equal to 3. We find the domain of G. We can plug in whatever we want into G. Cool. But whatever I get out of G, I have to be able to plug into F. That means that G of x cannot be -1. So for the domain of the composition, f of G of x, I can take the domain of G and simply remove the thing that's going to land me outside of the domain of F. So I end up with -infinity. Let's see here, up to 3. Don't include that. And then from 3 to infinity. So I've taken the domain of G and I have removed what lies outside of the domain of F. Take the domain of G and remove what gives G of x not in domain of F. Will this be super complicated? No, it really shouldn't be, right? Addressing these sorts of concerns should reduce to things that we've already considered. Okay, what content have we already considered? That's the tools that we'll need in order to solve these types of problems.